So good day to for joining to machine learning with MLR3. So before I just want to finish you can go to menti.com. Go to menti.com, and type in the code 4994. Okay, menti.com. And type 49943272. So I just want to know where is everyone from. Just type in your city and your country. Okay, so some are from Sabah, Malaysia, Pakistan, what else? Okay. So then today, we have somebody from Africa. Okay, thanks for your information. We should start the webinar today. Put into slide. So as again, our user into MLR3 for machine learning in R. So if you are interested, you can actually have the slides. The slides here, I shall paste links into the chat. So we have the slides available at this link, bit.ly/MLR3-slides. So you can actually have the slides even after the webinar today. If you have questions, you can ask your question that the presentation. You can just go to this link .ly. Or click the link. If you can access the slides, you can have you can click the link in the slides. Okay, and also share that. So if you're interested, you can actually later there's a demo. I will demo how to use the MLR3. You can actually access the code and the slides in the GitHub also. So again, I will paste likes and questions and GitHub here. Okay, so or you can call me KH. As the lead data scientist in BAT, developer in machine learning, about running communities in Malaysia, teaching two communities Malaysia, flow and deep learning Malaysia user. You can find me in the link, Facebook. So like this event is actually R User Group. And also I founded help to actually organize more participants. And also I have a podcast where I in the country, the talk AI in the rest of podcast is also listen for free. So the agenda for today is what we use this MLR3 package to so basically we learn how to for example, how to create a task, a learner, train a model, and making decisions. And then we also learn how to use the MLR3 package to evaluate machine learning models. And then I will end with the demo. Demo is a Google Colab, so you don't store anything by using the web. Okay, so this webinar is on cover all the things. So in this webinar, programming, object-oriented programming, and machine learning. Programming and machine learning. So, introduction to MLR3 and a short demo of the usage of this ML package for machine learning. If you want to know more, there is a link of all the resources that you can go to, and also available in the slides at the end of the slides. Okay. So I just want to jump in. What is machine learning? So machine learning basically is a type of artificial intelligence or AI that allows the computer to learn without you explicitly program it. Okay. So it's different like doing a programming. Where you're doing a programming, you actually code and give instruction to the computer to perform certain tasks. So in machine learning, what you need to do is you actually give a lot of data to the machine, and then the machine will be able to analyze the data and find patterns inside the data. So from there, the machine will learn from the data given. So the main ingredient for machine learning is the data given to the machine to learn. If there's no data, then you cannot train the machine to learn something. So data is the main ingredient. So we talk about machine learning. So machine learning basically can be classified into two categories. One is called supervised learning, and another one is called unsupervised learning. So supervised learning, you can do regression. I'm sure you have learned regression when you're doing your secondary school. For example, you have y equal to mx plus c, where you draw a straight line. So that is a basic regression. Another type of supervised learning is called classification. So basically, for example, I have a data. I train the data, for example, to actually detect whether I have a COVID or no COVID based on the symptom. So that is what we call classification. Or I train a lot of data with the pictures of a cat and dog. So when I ask the machine to recognize the picture, whether the picture is cat or dog. So that is also classification. Okay. We call supervised learning. Supervised learning basically later explain basically is a data you have label, then you actually provide the label data to the machine to learn. There's another type of machine learning which is called unsupervised learning. So unsupervised learning means the data no label. So if your data has no label, you do not know what you're getting. Basically, what you can do is you can actually see how the data, because of the certain patterns, okay, or the certain behavior, you can cluster them together. You can group them together based on certain similar behavior. Or you can do some sort of what we call association. You can associate this data point with another data point, okay, because of similar attribute or similar features. Okay, so let me go deep a bit into what is supervised learning. So supervised learning basically implies that your data already got labeled. Okay, like I explained just now, you have a lot of data about COVID. So for example, cough or maybe fever, what's the temperature of fever. And towards the end, you label that this patient has COVID. Yes. Then maybe you have a lot of data showing this, and towards then this patient has no COVID. No. So that yes or no is what we label. Or you have a lot of picture of a cats and dogs, then you label this is a picture of a cat, this is a picture of a dog. So that's called what we call label. So label, you actually tell the machine that this is how data for certain behavior. Then the machine will learn. Okay. So for example here, okay. So for example here, you have a graph that shows the total bill amount. Let's say in the restaurants, then I see that how much the person pay for tips. Okay, so how much the person pays for tips and how much the person spend in the restaurant. Then I also can see the differentiate between somebody who do a pickup or delivery. So from here, if I know that the person spends this much for dinner, then I know that this person will pay this much for tips. Okay, you label that this amount tips that you get. Okay, there's another type of machine learning we call unsupervised learning. So unsupervised learning, that means the data have no label. Okay, so unsupervised problem, basically you look at the data and see how this data, because of the behavior or because of the attribute, where do they fall in a certain group or certain cluster. Okay, so normally in unsupervised learning, you can do something what we call clustering. You cluster the group of data points together because of the similar characteristics or similar behavior. Okay, two supervisors. You have label data because your label data. So let's say the prediction say this is the value. Then the value you can compare with the actual value because you have a actual value that's label data. So once you compare the value, then you can see how far is your predicted value compared to the actual value. So you can measure the error. Okay, so this is a good thing about supervised learning. The machine can learn from data, and once he predicted, then he can learn that how far is the predicted value from the actual value. For example, the machine to predict whether this is a picture of cats and dog. So when the machine predicts this is a picture of cats, then you say, no, this is not a picture of cats, this is a picture of dog. And that this is, in the future, he will learn that this is all the data point, this is a picture of a cat. Okay. Whereas unsupervised learning, because there's no label, so you cannot know what is the. So what you can actually do is you can actually use a model to generate more example, okay, and look at whether this data, because they are not in the there's no label data, so you cannot measure the whether it's accurate or not accurate. But see whether the data point whether they are when they're in a similar cluster, do they exhibit the similar behavior or not? So basically, by learning, basically you view in the label data, okay? Whether there's label data, no label data, you build your model, you train your model, and then whether you do a prediction or you do a classification or you do a clustering, depending whether you have label or no label data. If you have a label data, then you will do what we do prediction and classification because you have label data. If you have no label data, then you're doing unsupervised learning, then you can do clustering. Okay, so basically, talk about machine learning, you have a lot of different machine learning, where we say machine learning can be supervised learning or unsupervised learning, or it can be deep learning. All these machine learning belong to a subset of what we call AI. So when we say AI, basically you have machine learning, all your machine learning, these are all the AI. So basically when you do AI, basically you're doing machine learning or you're doing deep learning, or you're doing reinforcement learning. So when you do a machine, like I said, you need a lot, you need to fit into the model. Okay. So basically, you have a lot of data that you train. Okay, you have the training data. Then, for example, let's say you feed in your data. Sometimes your data, 100 columns, or we call 100 features. But not all the features are useful that you need. Maybe you only select certain features. So this is what we call features. Okay. So you need to do some sort of pre-processing. Okay. So a good machine learning workflow, you need to do pre-processing. Okay. So a good machine learning libraries should allow you to do pre-processing, because whenever you deal with data, most of the data is not clean. You need to do a lot of pre-processing. Okay. So a good machine learning libraries, okay, no matter whatever libraries you are using out there is a component where you can do pre-processing. Okay. So after you have done pre-processing, okay, you will train a model, okay, and then you actually use so many different type of machine learning algorithms. Okay, for example, just now we say if you're supervised learning, you can do regression, okay, or you can do classification. So for classification, there are many models out there. Okay, so model, for example, you can do for classification, you can do this logistic regression. You can do what we call a random forest. You can do decision tree. Okay, there are many models out there. Okay, so one, you can to data with unseen data to see whether the model able to perform correctly or not. Okay, so to have a data has not been seen before, then you need to do pre-processing. Okay, and then you feed your data into this finalized model you have trained in a phase. Okay, and you compare to see whether the data predict and whether the error is good or not. Because remember, when you are supervised learning, actually you have labeled data. And the model predicts something, you can actually compare whether the value predicted is actually very near to the actual value. Then you can compare what's the error. Okay. So like I said, a good machine learning workflow will have allow you to help to do all these things. Okay. To do machine learning. Okay, so we know that to do machine learning, there's many libraries out there, many packages out there. Okay, for example, but the problem is all these machine learning methods, there's no one single interface. Then to do performance evaluation, it's very cumbersome and very troublesome. Okay, so this is where we said this is a problem we are facing now. Need to call the library like this. I define this is the Y, okay, and then this is the data that I need to train. Okay, then let's say I use boost. This is another way to call this model. Okay, you can see that because of different packages in R, it has a different ways to run the packages, and different, if you want to compare this model, then you have a lot of difficulty. So this is where concept of using one unified interface for machine learning in R by using this mlr3. Okay, so by just calling this library as mlr3, you can do the whole machine learning. Okay, where you can actually look at the data, you can actually look at the different learning algorithm, you can compare you can evaluate of different learning algorithm, also compare the performance. Okay, before we jump into this mlr3, there is a new concept in mlr3 where we use something what we call R6. Okay, so what is R6? Okay, so the mlr3 uses the R6 class system. So this is something that is what we call the object-oriented concept that you use in the mlr3 packages. So in this mlr3, we have this R6 class system. So everything will be based on this object-oriented, where object-oriented I use something what we call this class. Okay. So for example, if you learned R before, you know that we can use a $sign to actually call a new this features or column. But for this case here, we can actually create a new object for class using this new command. Okay. So for example here, let's say I want to do a classification. Okay. I use this classif, then $new. Then I define what is the data and what is the target. Okay. I explain more later in the demo. Similarly, once I have an object created, so the object is called class here, I can actually call, for example, $n row. So $n row here means I want to call this command. Okay, I want to know how many rows are inside this object called class here. So this iris data set, it has 150 rows. So you can actually call the information for this object using this command n rows here. Similarly, he has other methods. If you know that the object oriented, you have a lot of functions, what we call methods. Okay, you can method, for example, you can filter the number of rows, row number 1 to row number 10. Okay, you can use a command like this. Okay, and then if you learn object-oriented programming, we have something what we call mutation. You can actually define now. Just now we know the n row is a filter. Now my n row. So now instead of processing 150, now my task to just 10 row. Okay. So object-oriented concept is actually play a very okay. These are MLR3 package. Okay, so this MYRUG package, it has this what we call active binding. So basically, active binding means you can actually use to call this variable. For example, this variable here, okay, n row. So this n row is actually a variable to call the number of rows. In case here, you cannot say task number of row equal to 11. So you get an error because this case, this n row here is to call and return assign any value for this n row. So if you try to assign a value, you get error here. Similarly, if you use active binding checking, for example, I will say task properties, okay, task $ properties. I try to call the properties for task. You find that there's no value, there's no value. Okay. Instead, now you can actually call as a property 1 or property, and you can actually look at the value for this case here. So the MLR3 philosophy, okay, what's the MLR3 philosophy? Basically, the MLR3 philosophy is we want to overcome the limitation of S3, okay, with this help of with the oriented concept. So now, so you have a data method. We call it the object-oriented concept, and then you have active binding, where you can do a semantics. Data table. So study this tidy words. It's similar to data frame, but data table data this our tree is on the. Remember one of the problems with in machine learning is use packages, and all these packages has a lot of dependency on other. Okay. So by having one unified this interface, this MLR3 will try to make sure all the dependency will be very light, all the packages without a lot of dependency. Okay. So for example, you have R6 data table. These are the main packages, and then there are some packages specifically built for this ML3, like for example, backport, checkmate, and many more. Okay, so then from there you see training, okay, and testing. So you train, you build what we call a learner. Okay, once your learner learn the training data, then you feed the unseen data, which is the testing data, into a model, and you do a prediction. So then you do a prediction, you measure the performance, you measure that the data predicted from a testing data set, how far is the value predicted compared to the actual value. Okay, so then know that if the model is very okay, then the prediction of the testing data, which is unseen data, is very good. Then you can see the error is very low. Okay, if the error is very high, that means the model has not learned enough to actually able to predict the testing data to actually improve the performance. So this is a common workflow that you do: load the data, split the data into training and testing, create a task from data, then choose a learner, okay, train the prediction, assess and interpret the data. Okay. Okay, let's look at the data. Okay. So will be for this mlr3 is in the form of tabular. That means you have a column and a row. So you have a column and row data like this. Okay. And then you have features. Okay. So these are the features that you will feed into your training data. So features is basically your X. Then you have a target. The target is your Y. You need to predict. Okay. So normally, if you are doing classification, the value will be discrete. It means you will dengue or no dengue, or whether I have malaria or no malaria. So the value will be 1 or 0, yes or no. Okay. But sometimes when you do regression, okay, the value can be continuous. Okay. So let's say you do Y equal to mx plus c. You want to, for example, predict the value of a house or predict the value of a sales. Okay. So the value of sales is always continuous. It's not fixed value. Okay. So when you do regression, okay, for this mlr3, you have a task. Okay, the data will fit task. Okay, so let's say we have iris. Okay, so let's say we have iris, the data set. Remember, the iris data set has 150 rows. Okay, for sepal length, sepal width, petal length, petal width, and then you have your label or your Y, the species. Okay, so this whole thing here will be your features. Okay, the purple color, and then this whole thing here will be your target or your feet or your this Y. Okay, so from there you can actually the data will be what we call a task. Okay, you define that the iris will be your task ID, then the data is the iris data set, and you define what is your target or your Y, the species. So from here, this is a species, the column name is species, this will be your target name, and the rest will be your X, which is your features. Okay, so after your task, then what do you do? Okay, you can actually print. So when you task, that basically you explain, you can task. For example, you can see the attribute of the task is 115 times 5. That means it's 150 rows. And the target name is called species, and this multi-task. Okay, you have 3 tasks in your this iris. You have Setosa, Virginica, and Versicolor. And then you have 4 features. And these are all the other call just now. Just now we have C, we can check N row. We also can have N column, features name, target name. The rest you can actually something mutation, or you can then this is, you can say you can select filter, you can bind, or you can actually do a column bind or R bind. Okay. So in MLR3, we have something what we call dictionaries, allow you to simplify your tree. Okay. So for example, if I want to, you can just call. Okay. If I want to have a new learner to call my this machine learning out, yes. Or if I want to, okay, and then when I want to do resampling, I get MP. Okay, is measure and what is resampling. by use this package inside this MLR3, which is MLR3. So for example, just now we have a task in it. Okay, so when you in MLR3, there's a lot of this data set already available inside this MLR3. Okay, so one of the data just now we play with iris. Then there's other data set. Okay, you have the Boston data set, breast cancer, PIMA, empty cars, wine, zoos. All these are other inside your task object inside this MLR3 package. The object, the iris data set and columns, and then the target name is, and then I have all the 4 features. So what I constructed the task object, I can actually now define the learners or the machine learning algorithm that I want to use. Okay, so there are many machine learning algorithms or what you call learners inside the MLR3 package. Okay, you can do classification, you can do this logistic regression, you can do multinomial, you can do naive Bayes. There are many packages available inside this MLR3. Okay. So these are all the common machine learning algorithms that you can straight away that you can actually call and use inside this MLR3 package. Okay, next I will go to algorithm. So basically, like I said, whenever you have data, you need to split your data into training data set and testing data set. Okay, so remember, data into training data set and testing data set. Every the training data set or testing data set, it must have the what we call the features, the X value, X1, X2, X3, and then you must have your this value that you need to predict. So this one is your supervised learning. Okay, you have your label data. So then what you can do, you can actually define what are the learner, what machine learning I will use. Okay, so for example, this is and you can do supervised learning. Supervised learning, machine learning, you get classification. Okay, so you can do many different machine learning algorithms, or you call learner. Once the learner have learned the training data, then you can use the model to do prediction. So how do you do prediction? You feed in the unseen data, the testing data. Okay, you feed the features, the X, and then your model of that you already learned to you do a prediction. Okay, so then what do you do? This green blue with the original label from the testing data. Then you know how far is the prediction, the predicted value from the training compared to the. Okay, so that is how the learner will perform. Later you do the, I'll show you how you do the evaluation. So in the learner algorithm, you have the feature type, packages, properties, the predicted type. For example, you can predict response or you can predict error, and there are many parameters that you can set. Okay. Later I show you the demo. These are the parameters set inside your this learner algorithm. The learner algorithm, for example, let's say I want to do classification. Okay, I want to do classification. I want to do a decision tree. Okay, so I call a learner. I use the dictionary LRN. And I want to train the data. So I train. The task is the data that is iris data. So then after I train the data, I can actually see what are the value that is being trained and what is the output. Okay, so because this is a decision tree, okay, because this is the decision tree classification, you will say that anything that is below 4 petal length, anything below 2.5, you classify as Satosa. Anything is classified more than 2.5, okay, you classify half versicolor or this and then so you actually build the rules, okay, automatically decision tree. So you can actually so let's say if you train with decision tree, then you can actually use this model, okay, to explain how this decision tree comes to be. this prediction. Then you can set other hyperparameter. For example, in decision tree, you can set, there are many parameters you can set. For example, how deep is a tree? Okay, how what's the depth of the tree, and where do you split all these things? Okay, so any parameter that you set, and all these parameters you can set, okay, inside this param setting here. And then if you change the parameter, you can actually list out these are the parameters that you want to change. Okay, again, the model with the new decision decision after you change. Okay, so now I have trained a model. Now what can actually feed in a new data? For example, let's say this is I create a new data. Okay, I say, let's say this is the sepal length is 4, the sepal width is 3, the petal length is 2, the petal width is 1. Species. I have a sepal length 2, sepal width 2, petal length 3, petal width 1, 2, the species to be predicted. So I can feed this new data to the model. I say the learner now predict this new data, that predict new data. Okay, predict that first row here, 4, 3, 2, 1, the predicted species. The second 2, 2, 3, 2, versicolor. Okay, how we actually, after the model being trained, we actually use it to do. Okay, so the value here, okay, this is the value that is responding predicted. Okay, remember this is the green prediction. Okay. Okay, so once you also can change instead of predicting value, you can actually change the predicted type into a probability. Okay, you can change the predicted type into probability. For example, I can see here the for the row number 1, the probability of predicting Sentosa is 1, the rest is 0. And then for the row number 2, the prediction is actually 0.5, 0.5, half. Okay, and half Virginica. Okay, so this is how you can actually see that whether how accurate is the, for example, the second row here is actually not very good, that it's half the probability of Versicolor and Virginica. Okay, so the prediction of if you want to see what is a prediction object, okay, you can actually use this convert the prediction object into a data table. Then you can actually see response. Okay. For example, the response, the prediction is Sentosa or Versicolor. Okay, where there's actually 3 species in the prediction, supposed to be Sentosa, Virginica, but for this prediction, you predicted Sentosa and Versicolor. Okay, of course, you want to look at the performance. You want to know that how good model will. The model will green color here. Well, ground truth. Then you know the, okay. For example, let's say out of 100 label, the model predicted 5, right? So the accuracy is 50%. Okay. So let's say out of 10 row, the model is incorrect. Then the accuracy is 80%. Okay. So this is how you measure the performance. When you have the predicted value compared to the actual value. Okay. You have a known data. Okay. So the known data is Sentosa. Okay. Then you can say, oh, the value predicted is Sentosa Virginica. So for this case here, so the predicted value is accuracy is 50% because the is wrong. Okay. So it's correct. This is wrong. So this for this case, so it's 50%. So you compare. So what you can do, you can do a score. So the score the 50%. You can do is you do what we call sampling. So resampling, basically you have this data you feed into a model, but you split here as a test. This has your testing data set. Okay, so you split down here this number of row down here as your testing data set. For example, let's say you have 10 row. Okay, you split the last 2 row. Okay, has your testing data set, and then you feed the 8 row into your training data set. Okay, then you compare the last 2 row into your actual performance. So what you can is, okay, you can actually change where you actually split the training data set. So actually split the data. You want to do that because if you only split in one location, sometimes the data will show the whole picture of the data set. So you need to split different points, the speed of training and testing, then average out the result. And this is what you say, my model has learned all the data from all the data points of my performance. This was okay. So this is the training, this is the testing. Where you split, okay, is not always fixed location. So what this is what cross validation. Okay. Split and you split and you get result called cross validation. Okay, so it's called resampling. You can just use this command RSMP. Then you say you want to do C. How many times you want to do cross validation? You want to do 5 times, 5 different splits. So 4 is 5. You just resample 5 times this cross validation and this resample. So this is what happened lah. So you sampling strategy. How many fold? For example, your cross validation, you want 10, you split 8 different times, different area. Or you want to split 5, then your cross validation will 5. This case here, this is 3-fold. That means you split at 3 different locations. Different fold, different. Okay, you average out. That will be the average of all the resampling of ready. To do a cross validation, when you aggregate the result is about this accuracy about 7%. So it's a resample. So then you can use the resample result to do it. Okay. Okay. So you also can see for every single fold, what is the prediction like? You can see, or probably certain fold the prediction is better, certain fold better. Okay. And then you can see every single fold performance. Okay. And comparison, for example, different for example, okay, measure the. Okay, so you can actually compare two methods. One is 3, another one is scan. Okay. So now they are set, the wine they are set. So I classification method. Decision tree, one is can. The different asset fauna perform better. And then for one data set, the decision tree also perform better. So you can see overall, classification decision tree perform better to KNN. Okay, so this is how you do. You can actually you can see you can run method for different results. You can see the code is very, very short. Okay, and then you can just run people algorithm, just compare the result. So you can compare the result using resampling, and then you can actually assess it by converting the data, this data source table. Okay, lastly, you can measure this mlr3 with package. mlr3 is a similar ggplot2 package. So you can actually see for this result here, okay, this decision tree always perform better. Okay, for 3 data sets, the IRIS data set, the fauna data set, and the wine data set. So the accuracies are all higher compared to KNN. Okay, then you can one good thing about this MYRUG is, okay, people say how it's slow, but this MYRUG is also able to run core. Okay, so it's distributed. You can run your this code in multi core, so you can actually run it in parallel method. This can actually increase. Last one is how do you get help? Okay, one of the most important things on the slide here, you can is an ebook available online. Okay, using the help packages available in MYRUG, you can just use it, or you can actually call the help function. So lastly, this is the thing that for data, we actually use a task for class. Then you can compare performance. Okay, you can do resampling, you can do measure, you can put multiple learner, multiple by using this benchmark. So you can see the for MLR3 is very wide. Okay, you can also do deep learning, like you can have this Keras or Porsche. There are many. Then you can actually learning pipeline. Okay? You can do pipeline, like spatial object. Another thing that maybe you can do is you can do hyperparameter tuning, a whole package of tuning, and then you can do visualization. So in conclusion, machine learning is very powerful tools. MLR3 is a powerful machine learning libraries that's actually made and train machine learning model with. So I will show the demo is available in. I will copy the link again here. Sorry, if those are come late. Of the slide in the chat, you can actually connect to me LinkedIn and Twitter. If you want to know more, the resources are these are all the websites that you can go through. Okay. Okay, so if you go to that link, to the demo link here, you should see, you click this, you should be able to see this. Okay, so I'm going to demo you the code Google Colab. So because Google Colab allow me to show you the code without. So let me, okay, the link is inside my LinkedIn, inside the, so like to me link. This. Okay, so first run the or we just call install the keywords on the GGLE. This is after that you can call the libraries. So let's look at how do you use this mlr3. So I'll use the iris data set. So remember that sample view. This is your label, the species. Okay, then I can actually create a new task for the iris data set. So this is the iris target, this iris data set, and then this is the features. So I create a task. Okay. So once I have a task now, I can do the plot to see my data. See, this is the plot that is your data. Then I can see task now. So if I call a task, I say that I have 150 rows and 5 columns. Let me zoom in a bit. Okay. And then my target is core species. And then this is a multi-class and 4 features: petal length, petal width, sepal length, sepal width. Remember just now I say I can call n row. So n row will give me number of row. Number of row is 150. Or I can call here task $sign n code. So n code, sorry. So n code will give me number of columns with five columns. Okay. So it's the same here. I'll just show you n code here, 5 columns. Okay, next after data set now training. I want to do training. Remember to need to define my model. Then so I do decision tree. I give a, so this learner is a class that's going to call our Asian package. So now I can actually use the and train my data task. So you train now. I've trained already, so I can actually call to see what is my model being trained. So you say that 150 the number of row, and then I'll do a split. Okay, and then this is the split of my decision tree. Okay, then I can check the parameter of my decision tree. Before I check my parameter, make sure I convert it to a data.table, data frame. I can check my parameter. So you can see all the parameters inside my classification decision tree. Set depth of my tree, number of split variable, what you can put. And here I can change the value. So let's say I change the maximum depth to 1, the x value to 0. So I change the behavior of my decision tree. I train again because I changed my learner, the parameter. I train again. Then if I see my model again after I train, okay, so you can see the value of my decision tree now is the number of depth of my tree is lesser now. Just now, remember my depth, I have 3 values in there: 1, 2, 3, 4, 6. Okay. Now because I changed my depth to 1, okay, now you can see it's only petal length and petal width. The trees have been trimmed. Okay. So after that, after I've done that, okay, maybe now I can create a new data set. Okay, remember I want to do a prediction. So I create a new data set. So then I can actually fit the new data set into my this train model to see the value being predicted. So let me, okay. So now I create a new data set. So this is my new data set just now. Sepal length, sepal width, petal length, petal width, 4, 3, 2, 1, and 2, 2, 3, 2. And so I want to know what will be the predicted value. So the predicted value for the first row is Setosa, the second row is versicolor. Okay. Then if I change the prediction to probability, then I can see the prediction probability is like this. The probability of Setosa is 1, the probability versicolor and virginica is 0. So, but for the second row, the probability is 0.5 for versicolor and 0.5 for virginica. So that means because the tree, we trimmed the tree just now, so not very good. So it cannot correctly for this versicolor or virginica for the second row data. Look at the prediction. Okay, so the prediction is the first one is Setosa, the second one is versicolor. Okay, if I want to look at the prediction value, I can say the prediction value, I can the function response. So the response is Setosa and versicolor. Let's look at so the second example. Let's say I use a data set which is the penguin. Okay, so again I can create a new task. So task, I call task penguin. So for this case here, this penguin data set is 334 and 8 columns. And the target, the Y is species, has 7 features. What are the features? They have body mass, flipper, year. Okay, so again, the first 3 features are integer. The second 2 features are double or float. Okay, and then the last 2 features are factors or categorical features. Okay, so again, I'm going to use a decision tree. Okay, I call the learner. For this case here, I'm going to use what we call, I want to split my data set. Okay, I want to do a split training data set and testing set. So the rate is 0.7. 57% of the data will be split as training, another 33% will be split as testing. Okay, this is what I'm going here. Although training data set. Then we predict using the test set. So the train set is the one that you feed into the learner, the training, and then you predict using the testing data set. And what I do, I want to measure the performance. So the performance, I can use a confusion matrix. Okay. So for this case here, this is a confusion matrix. That means if you know confusion matrix, the diagonal are the correct value. So this 5, 0 is wrong. Okay. So this 6, 1 is wrong. And then this for Gen 2, the prediction, right? The rest of 2 prediction is not made. Okay. So you can measure you can use performance. So for example, the accuracy here is about 97% and 0.965%. So this is the measurement that you can use. So like I said, this is that's how we can use a confusion matrix. This is a confusion matrix that we have just now. Prediction. Okay. So the truth, okay, for different species, okay, how many percent is correct, how many percent is wrong. Okay. So this is, you can just compare the prediction. Okay. Next, like I said, you can do cross validation. So for this case here, I want to do threefold. Okay, I want to do 3 times the fold. Then I use the sample to train the data again. Okay. Just 3 lines, I can just do that. You can see now after I run, I can get 3 results. You can see the first fold, the result is about 0.965%. The second result is better, 0.97, and third result is not so good, about 92%. Okay, so this after what you do, you aggregate the 3 results. Okay, you aggregate 3 results into 1. Okay. Last one. Okay, I will show this. So we have 3 classifications. Now I want to show you regression. Okay, so I will use this Ranger library here. Let me install this Ranger library. Okay, so basically, what we do is use this the data set that's available in your R. So this, we're going to use this empty car data set. Then we are going to create a task. Okay, for this case here, we're going to do regression. So we say we are going to use this as task regression. So we know that in the data, and then we are going to do regression. So remember regression, the value, the Y value is continuous. This package ranger, because this ranger is one of the regression analysis that you can actually use inside this MYRUG package. All this ranger package. Okay, I this I show you now. I'm running now, so it takes some time. So now I create a task for this empty cars. Okay, then from there I can look at the features name and the target name. So the features name will be all my X value. So my features name is I have features name called AL, this track, gear, HP, all this, MPG. Okay, so target name is MPG. Then I will create a learner. So for this case, I'll create a learner. So the learner is your regression learner. So you can see this is a regression learner we are using now. Okay. Then I can look at the parameter. I can look at the model. So what are the parameters that I can actually use? Really, I can actually do a train test speed. Okay. So I can actually do a train test speed. So I'm splitting again to 1% for training, 30% for testing. Then I will say I'll train. I will predict step. Then I can actually measure the response. So these are the value predicted for my testing data set. Truth here. The actual value, and this is the predicted value. Okay, so there are value difference. The difference here, this actually is your prediction. So the line here is your model, and these are the predicted value. This is actual value, and this is the predicted value. So you can see the bar here is how far is your predicted value to the actual value. Because the MAE is your error. Okay, so you can compare the mean absolute error. So the mean absolute error is about what? You look at the score. Okay, so the score for your mean. Okay, another way to measure the regression is to measure error. Okay, so you can actually call MSR, the measurement for MSC, and look at the score. So the regression area here, you can actually see the it's about 0.0. This is a MSC. So you can actually look at MAE and look at MSC for this performance measurement for regression. So they're more for classification and for regression. Visualize the data and break split the data into testing, and there are many things You can see the code is quite short, and now you have a unified interface for this machine learning. So more, you so you have actually referred to. Okay, so this ebook is very, you can, so okay, and then you can actually do evaluation of your model and resampling and benchmarking. Of course, we cover other things. For example, you can do hyperparameter, you can do like feature selection, pipeline, and many things that you can do. But this today the webinar is to introduce you about this mlr3 package. Then you can actually see that you can actually have this one single unified package package for doing machine learning. So in conclusion, there are many resources here available. You can refer to. You can connect to me, LinkedIn, my Twitter or GitHub. And so all the resources available here. Okay. So this is of the presentation today. If you have any question, you can ask in the. There's no question asked, or you can ask in the chat. If is there any questions? So the GitHub is also available here. You can now. It's also available here. You can actually click on this. You can see the code again. And then you can also click on this and open it up in Google Colab. You can run. So resampling, you can actually look at the slide. Okay. So go to the slides. So here, go to the slide, you can see the code for resampling. Okay. So you can actually look at the slides. Even the code here has resampling. So here, let me show you again. Here. So we say we are going to resample cross-validation 3x4, and then we resample, call the data set and call the learner, and then do resampling. Then you have assigned to a new variable called new object called RR. Then you can do RR score of the value. Is there any other question? Okay, so I think yeah, if you maybe you still need to go back and look at the slide. So hopefully you can actually go back and look at the slides that again. So let me copy again the slides. Sorry. Okay, so go back and look at the slides again. Then click from the slide. You can click to all the link that you have, and then look at the GitHub. And then from the slides, if you need more reference resources, you can actually go to the end of the slides. So you can actually go to the end at the resources link that are provided. Okay. So there are many things that you can actually see. Look at most important thing. Look at the MYRUG website. Read the ebooks. Then there's also a cheat sheet. Let me open the cheat sheet here. So there's a cheat sheet available for our official. Okay. Let me see. So there's a cheat sheet available that you can refer to. For example, how to create a task, how to create on train per day. Okay, so thank you very much for attending. If you have anything, keep in touch. You can contact me LinkedIn or Twitter. Look for, I will connect with you over there. Thank you very much.